I want to close out this chapter by giving you a high-level overview of the Kubernetes cluster architecture. This will give you a basic foundation in order to understand the various components which help Kubernetes do its job. A Kubernetes cluster is made up of one or more nodes. A node is a physical or virtual machine in the cluster. Kubernetes doesn't make distinctions between the two. Kubernetes has a master worker architecture, roughly speaking. A master node hosts the master processes which manage and control the cluster. On the other hand, worker nodes host application containers. The control plane is the set of four master processes. They are a scheduler, an etcd cluster, a controller manager, and an API server. A Kubernetes pod holds one or more containers. The kube scheduler process decides where to deploy each pod. Therefore, the scheduler effectively decides which node each container ends up running on. etcd is a highly reliable distributed key value store. Kubernetes uses etcd to store all cluster-related management and configuration data in a fault-tolerant manner. On the other hand, a containerized process saves its data in its container or in a volume. The kube controller manager is technically a single process. Conceptually, however, the controller manager is made up of multiple logical controller processes. Here are some of the controllers. The node controller is in charge of keeping track of which nodes are currently in the cluster. It also tracks which nodes are healthy. The replication controller always makes sure that the specified number of pod replicas are running. It is responsible for rescheduling pods and containers when they crash. There are more controllers, but you get the idea. The API server process acts as the interface between the master processes and the rest of the Kubernetes cluster. The API server exposes a RESTful API. This is ultimately how you control the Kubernetes cluster. Unless you end up writing a tool which communicates with Kubernetes itself, you probably won't deal directly with the REST API. You will manage your Kubernetes clusters through the web UI or the command line tool called kubectl. These interfaces then communicate back and forth with the cluster on your behalf via the API server. Let's talk about the web UI. It's a dashboard through which you can manage all aspects of your Kubernetes cluster. I feel that the web UI excels in giving you situational awareness of the state of your cluster. One thing to keep in mind, though, is that the web UI is not installed by default. One day you might find yourself trying to troubleshoot a cluster which doesn't have the web UI. That's why it's important to know how to use kubectl, which is always installed. The kubectl utility, or as some people pronounce it, kubectl, is the command line tool for managing your Kubernetes cluster. It'll probably be your primary interface once you get the hang of it. You'll learn how to use kubectl as we go through this course. At the end, I'll also give you a tour of the web UI. Every worker node has a set of special processes called node components. Here are the three most important node components. The kubelet does things like periodically check to make sure that the containers are still alive and relays that information onto the API server. The kube proxy facilitates container networking so that containers can easily communicate with each other no matter where they've been deployed. The container engine is what actually runs containers on behalf of Kubernetes. By default, Kubernetes uses the Docker Container Engine. But as of Kubernetes 1.8, the Rocket Container Engine, spelled RKT, is also experimentally supported. That's it. In the next chapter, we're going to cover some foundational topics like YAML and a basic Docker review. Thanks for watching.